on the principle of deep representation learning, right? Or mathematical principles of deep learning, or more generally, intelligence, a lot of people, or artificial intelligence, whatever you call it. So welcome. So this is actually a course jointly from Data Science Institute of Data Science and also School of Computing Data Science. So mostly this is for students, the first year graduate students or senior undergraduate, as the sort of the level of the course was designed for. And before we get started, sorry for being late a little bit, a few minutes. Well, I didn't know this is the first day of the school. I tried to get my coffee. Turns out that I didn't know that the line is so long, so it's delayed a few minutes. All right, just some basic information about why there's I don't know, not hearing anyone. Anyway, just something about. No. Okay. So I need to see the slides, by the way. Why I'm not seeing my slides here? Okay, here's better. Yeah, good. Oh, anyway, I don't know if that bothers you. Can I reach that one? Okay. All right, good. Why there's something? Shoot. Those are really annoying, huh? Shoot, I don't know what's going on. Anyway, I don't see it here. That's the problem. Okay, good. Hopefully that won't bother you. So first of all, right, so this is, as I say, I'm the instructor of this course, and there's some teaching assistant, Tianze Chenfeng, and also Xian was my previous postdoc. He's also a previous TA for I offered this course last fall with some of the temporary version of the course. And they will be primarily help you go along with the course. And in fact, just a few words about this, right? So this course has been in preparation for a long time, right? So even during the summer, there's been a lot of preparation, getting the textbooks, get the website, get all the materials ready. There's a huge team of people besides those two. There's actually a team of students at Berkeley, my actually PhD students, postdocs involved getting the course ready. And also they will probably also help remotely with some of the course material and some of the homework assignments that you will see in the future, right? So basically behind the scene, there's actually a team of a very huge team of people helping preparing this course. I will give them credits later. So lecture time is 2:45, and we'll be here. Right, that's the location. And as I said, primarily, I believe everybody interested in this course, just like me, right? Everybody interested in, almost everybody's interested in the past 10 years. There's been a lot of excitement, advancement about curiosity, mystery about intelligence, right? People are curious about what it is. There's a lot of practice with deep networks, large models, and so on and so forth. And made a lot of technological advances, but then there's seems that there's been a little bit lacking about understanding what deep networks doing. What is really can there be a scientific or mathematical approach to understand intelligence, right? So that has been on my mind in the past 8 to 10 years, to be honest. Being on many of my students' research agenda in the past 8 to 7 years. So since I went back to Berkeley, there's a lot of work. So only up to about 2 years ago, 3 years ago I joined Hong Kong U, and then also start to prepare some of the new courses for IDS. And we realized that I look around, there's a lot of interest in deep learning, deep networks, and also machine learning, and the large language model, and so on and so forth, right? We look around the courses for graduate courses. Honestly, the situation, so we will look at all the top university, all the courses, machine learning, deep learning, artificial intelligence, and the language models, and so on and so forth, and computer vision. The situation was very appalling, right? 2 or 3 years ago, So you are new graduate students. Many of you probably come in with this assumption that you don't have to hear, you have nothing to learn, right? You're here just do things. That's what's exactly the mindset. Now the top students go to Berkeley or Stanford. They don't go to classes because all the graduate students, graduate courses has nothing to offer. Okay, they can directly be TAs. They don't go to courses. They don't go to group meetings. They go there to work for the professors. After a few years, get a degree. That was been the mode. Okay, they think they know more than the professors. That has been the cases because all the courses is completely outdated, right? Either the traditional courses hasn't been updated for 20, 30 years, or some of the new courses are just talking about those networks as tools. And it turns out the student knows more about the tools than the professors, right? The professor has nothing to learn, right? Because all the students has been interns in the top companies, Google, Microsoft, Meta, right? They know more about the data. They know more about the tools. They know more about the open source resources than any of the professors at Stanford, Berkeley, right? The sentiment is that all the top students don't go to classes. If needed, there will just be the TA for the classes. So all the students, it's very weird, right? The ECS courses, top university, right? In the top universities in the world, the ECS, the courses, graduate student courses, are very, very popular, by the way. Those courses, then you ask yourself, who go to those courses? They're extremely popular, right? Student not from ECS. It's very strange, right? So that's the situation because why? The courses is very outdated. I mean, there are both pieces meal. And by the way, it's very interesting, right? All the courses, if you know, I mean, nowadays it's open source. Everything is, you can find the courses from MIT, Stanford, Berkeley, right? All the courses, many of them are recorded. You can look at the lecture notes. Go look at them, right? They're all exactly the same. I was joking, right? Even 来强绩效, if they take a course, will be exactly the same material, okay? Right, that's such a situation, right? So that's no wonder good students that, right, they have nothing to learn. They believe they have nothing to learn. They're just here to work, get a degree at Berkeley, get a stuff, and then go to work for the companies. That was the situation, right? So people are worried, and we were worried because we actually, to some extent, the professors we are to blame, right? Because if we have to wonder, then what else we have to offer, right? If we can understand something better than students, we cannot teach students something new, then we're in trouble, right? So actually, unfortunately, we are in that era now, right? Because the AI has reached to a point to make knowledge dissemination much, much easier, right? It starts to level the field, right? It used to be there's a big difference between elite education and also, mediocre ones. But now that gap gets reduced. Like Elon Musk said, right? Why should I go to school? I can learn anything from the internet. But he is a point, right? Given you are a self-driven, you are self-motivated, you are a self-disciplined person, yes, you can do that, okay? So that's actually the situation, right? The question is, what do we do here? What can universities do, professors do? So this actually has been where we have a little bit soul-searching moment about a couple of years ago, realized maybe we have to do something better. We probably have to completely change the design of the courses. Start with the HKU, right? So that's actually what. So, I mean, you will probably be the first cohort. Shoot, where's my mouse? Where did I move my mouse go? Okay, here, thanks. So you are in some sense you are the lucky one. So we actually, why this doesn't work? This should work, right? Okay, why I didn't go to the site? This is weird. I mean, should I just have to quit? How do I quit? Jesus, there's something not synchronized with my website. How do I quit this darn thing? Okay, good. So, all right. We can go to the website. So if you click, there is actually So the textbook will be based on now it's there is a form of textbook. You will be the first one to experience this type of book. It's very different, right? There's a website dedicated for the type the book, right? So you'll see that has all the book, and you can download the PDF version, right? There's a team of people who are actually editing the book constantly. So in LaTeX, right, underneath, but it's everything synchronized. We'll constantly update this. So the PDF file, the version will be available there. You'll see. We just released this about a couple of weeks ago. And there's also, if you don't like PDF, you actually can just, there's also the HTML version. You can go to every chapter. It's actually all synchronized with the LaTeX, right? Chinese, English. So this is the English version. And you can go to, this is actually HTML version, and also this is a PDF you can download. And everything is open sourced, including LaTeX file, HTML file. Everything is open on the GitHub. So you can, a lot of people are actually already contributing to find errors. They can actually, if you find anything wrong, you can submit your query request to change. And a small thing as small as typos or any suggestion you find that anything is factually incorrect, you actually can contribute, right? So there is a, contributors, right? You can see there's a core team of authors. Those are my two postdocs, and this is my current PhD student. And there's already people you can see, right? There's, of course, there's people help with Chinese. We'll talk about that later, the Chinese version, transversion. And my former student works at OpenAI. And this is, and also you can see there's already people making substantial contributions to the book. We just released about a couple of weeks ago, right? This is the VP of Google DeepMind, Kevin Murphy. He spent 5 days not doing anything else, finished reading the whole book, and he's giving extremely detailed comments on all the chapters, right? Dozens of pages of very careful type. So you can see people are very encouraging. There's a lot of people actually already correcting things, making a lot of suggestions. We're going through that. The book will be updated. Everything's open sourced, crowdsourcing. Open sourced, okay? And also that a couple of my students are helping the TA, and my current student will help with the web development and infrastructure. We'll talk about that in a second. So you can see this is going to be a first open source book and organized over GitHub, over Leaf, and also HTML. And also we have, if you go there, there's a Chinese version, and it's complete done by, very much complete done by AI translation, right? So everything, again, PDF, HTML, if you want, you can go to any chapters to read them in Chinese, right? You can see the contributors, right? One of the person helped with Chinese translation, right? Korea was my former student. He's the CEO of Mita Keji, right? Actually an AI model that trained the Chinese English translation. We use their tool, Translate. And people like the TA, Tianze, and my students, they helped with using Gemini to reformat it so that it completely compile from English LaTeX to Chinese LaTeX, and then to HTML, right? Everything is done automatically in very much, and you can actually update. So the English Chinese will be synchronized in that way. And so you can actually see that people are, including websites, everything will be translated. So this is the Chinese version. We heard, right? So just after we release the book, remember all the files, including Chinese, everything is open source. Everything is in GitHub. So you guys kind of have some fun. Right? We already heard that there's people already translated the entire book to Romanian, Romanian. They already submitted in GitHub, pending us to verify. Nobody reads. Unfortunately, nobody on the team understands Romanian, so we'll see. Yeah, I don't. Yeah, I'm sure that there will be a Japanese, Russian version soon, right? Indian version. We do have a team. My student Drew is an Indian. So I already asked him maybe he should consider translate everything to Indian of some sort. So that's actually the start, right? So everything is on a rolling basis. So the whole course you probably will enjoy how things gets updated. The whole website will also be changed. There'll be more resource gets pulled in, tutorials, other activities, many related topics about intelligence, the blogs, other websites, and all the things, teaching materials, all going to be. This will be one hub for you to study, teach, and research. Okay? You don't have to go anywhere else. So it's start with studying, right? So I assigned the job for my TA so that because now finding TAs we're trying to see. During the summer, we've been very busy, and thanks for people like Tianze. We actually developed a customized chat box for this course. So basically, all the book has been fine-tuned, which you use Tianwen, 7B or 32B, both versions, maybe other versions too. We created a knowledge entity, and the details you probably will learn how to do this. And the fine-tune or retrain a open source classifier. So now this is actually, this chat box is expert about this book. You can ask any questions. If you're a shy student, you don't come to my office hour or TA's office, you don't afraid of to ask questions, or you maybe think your question may be too stupid to ask. Now you don't have to be afraid, right? You can ask anything about the book, the concept, anything you can query about the. And in the future, we'll also continue to improve the chat box. Maybe you can also ask a question about any prerequisites. You have some concepts about linear algebra, things like warm up. We'll try to improve that as well. So the chat box will also be updated as soon as possible, very, very quickly. So this one you can also try. And there is one page. Currently, because the cost, right, we can only host the 7B one. It's based on, this also tells you a little bit of how this chat box was trained, was updated. And maybe in the future, there will be more so AI tools here. This is the first one, right? Also, all those chat boxes themselves are open source on Hugging Face. Right? You can also contribute to improve them yourself if you want, once you're familiar with those. Okay, everything is open source, right? And in the future, we'll have more AI helpers, assistants for this course. Help teaching, help research, right? There are other teams that are developing different AI tools for this. So basically, this course will be about the principle about AI, but also will be by AI. Okay, we'll study about the principle. You'll understand what is the principles behind the current AI technology from a theoretical point of view. Okay, but also you're going to experience through understanding that. You're going to experience firsthand with those tools precisely what they can do, what they cannot do. Okay, what they're capable of, what they're not capable of, to gain the empirical experience, feels about it. All right, so that's the purpose of this course. And along the way, you can also contribute, right? Welcome. This is an open platform for anyone studying, teaching, research. Everything will become a hub for this. Okay, so that's a word about the book, right? We didn't actually quite realize this. So in a sense, so we're in an age of AI, right? Intelligence. The technology has advanced a lot. In a way, right? This is what we thought about. This is the fourth book I wrote. I wrote 3 previous textbooks. Very traditional way, right? Write the book, find a publisher, do the editing. It took a few years. You spend 8 years write a book. You spend another couple of years go through the editorial process, right? Publish at MIT or Press or Cambridge. My previous book was with Cambridge University Press, right? Took about 1 year to just do all the editing, so, right? Get everything pretty and print it out, get a hard copy, right? That was 2022. Then we decided to translate to Chinese. That was 2022. We decided to translate Chinese. We tried the best translation model in the world. In fact, also by including Minkerei, right? The Bita Kejis. Actually, at that time, they do business on translating Chinese English for legal documents, right? It's actually a very good market. They actually make a lot of money, right? But we tried those tools at that time. Actually, it's not very good. They can translate paragraph reasonably well, but for a book, hundreds, 500 pages book, it's impossible. So we did a lot of pieces. You have to assemble them. It doesn't handle mathematical equation, doesn't handle image, right? Look at the files behind the Those are PDF, right? So those are the LaTeX, right? Like this. Right? Each chapter looks like this. Right? Each chapter looks like this, right? That's how you write a book. You compile, you get a PDF file, right? And now actually with the AI tool, right? So we did this try about 2023 before the large language model. And then we tested about all the best including Google translation, Microsoft, and also the Meta. So it's actually very, very bad. It then took us about 4 professors. So we did that. We cannot use that. We actually used so it took us about 4 professors about 2 years to translate this to Chinese. There's a Chinese version published in 2024, right, by 机械工业出版社, right, from Cambridge University Press took about 2 years. Worked very hard, right? So that was the previous book, very traditional way. Now, but for the new book, right? So this is about in May, I believe, late April, just beginning of summer. Have lots of. So we just about to finish the book, and then so I decided to give another try. I think it must has improved, right? But then I called Min Kere, said that can you try it again with your new model? He said the model is a little bit better, right? I'm sorry, the contributor, right? Min Kere. So then the same very light, I called him about 8 o'clock. So around midnight, he called me back. He said, well, I translated the first 3 chapters. Take a look. Right? He already put those 3 chapters in the overleaf. He said, you can already compile them. So I clicked the compiling. After that, I was quite in shock, to be honest. Right? So if I compare about 2022, if I evaluate, right, let's say the translation, 假设100分, if it's 100 score 100, the quality is about 30 to 40, right? That's 2022. But now at that time, so about in May, April, so I saw this. I read through at least the first few pages. I started to feel like this is about 85 to 90. Okay. So in each chapter, I look through. I think give me 1 week. I can, make it presentable, right? Correct. Just give a few days, work on it, and so basically the entire book about 10 chapters. That's about a couple of months, right? With a few helps, with help from a few students, you probably can do it in a week, right? Get the sanity check. So that's actually a situation. So just give you an example about this one task, translation, right? Reduced from 4 years of work by multiple experts, right, to just barely a couple of weeks in the past 2 years. Just how fast things are changing. And I was quite, surprised you can do that. Then later, my students at Berkeley told me, well, there's everything, LaTeX, HTML, PDF, everything, Chinese, English, they can actually connect everything together on the internet, right? So they can build a backend to support all this, right? So hence the barrier, language barrier is gone. So you guys maybe heard there's a lot of rumor, computer scientist is losing jobs, right? The fact is yes, right? Certain computer people are losing jobs, okay? Anything, your work is the nature of translation. Coding is translation, right? But remember, we're not a school of coding. We're a school of computing. There's a big difference between computing and coding, okay? Coding is just talk to the computers, talk to the machine. If you're only able to talk to the machine, your job is translating. You will for sure lose your job, right? So in the past, maybe the same amount of work required 10 people. In the future, maybe 1. Just like a translation, right? So you used to 4 professors, 2 years. Probably just 1 professor, 1 month. Okay, that's the situation. So do we need 4? No, 3 will be gone. The jobs will be gone. But you still need a professor. You still need people to know the content, okay? So this is something very different. I want you get it, okay? This is very, very important, right? That's including also the why Kevin Murphy, those are the VP of DeepMind, interested in our book, because they actually, right, they go for the content. They're probably the super programmers. They want to know what to program, not how to program, okay? That's more important, right? Hence, more reason to understand what is computing rather than what is coding. Coding is still necessary, right? Just like speaking English is useful. But just be able to speak English doesn't make you a Shakespeare, okay? So remember that there's a big difference, right? Between what's the value of understanding coding and so on. So use this to do something entirely new, right? Transform the notion of book. Right? So only during the summer, I start to realize, right, we're already at the age that the notion of a book is completely transformed. I wrote 4 books, right? The first 3 are very traditional classical books. Springer, right? The first 2 and then Publication House. I started realizing, right? So this course will be all about the knowledge. Intelligence is about discovering knowledge, right? But think about, we are in the business, education is in the business of organizing knowledge, disseminating knowledge, and advancing knowledge, okay? But think about it, for 3,000 years, 对吧？3000年啊 organizing knowledge, teaching knowledge, and advancing knowledge has always been separated in time, right? But once in a while, take some scientist, has nothing else better to do, write a book about something, 本草纲目, right? Then people try to then understand. Some people understand it, become a scholar, understand them, 对吧？或孔子论语啊, right? Then people started coaching, right? Teaching about them, teaching for hundreds, thousands of years. Then during that period, of course, the knowledge get advanced, right? Get develop better and better, until someone else has nothing better to do to write another book. Then people still do that, right? So that time start to from knowledge gets localized and the teaching and then advancing and reorganized. That can be spread in tens of years, hundreds of years, sometimes thousands of years, right? That era is gone. That's no longer the case. Now, everything can happen just here, one site, the same time. You learn it, you teach it, you change it, you contribute to it. One place, one site, right? One time. Everything happens simultaneously in one place, right? Also, in the history, for 1,000 years, the knowledge is always taught in spatially separated, distributed, right? Chinese teach Chinese. In Chinese, Russian teaches Russian, right? Language barrier is huge for knowledge dissemination. I myself learned mathematics, right? But one thing I really feel bad about myself is that I don't speak German in French or Russian. But a lot of good papers, mathematical papers, are in Russian, French, and Germans, right? You know, feel sorry, I cannot read the original papers. But now that's probably no longer the case. Right? You can see, right? This is probably the first time in the history, right? A technical book, right? Once you have the English version, you have the Chinese version. About 10 days later, there's a Romanian version, right? Can you ever imagine that, right? Just barely about a year ago, I think that's not even possible, okay? But this is true now, and we have to face it, and this is a new era, okay? So you're in that time. So we're going to use this course as a guinea pig, right? We'll test on ourselves. This course is about teaching people about what AI is, what intelligence is, right? The principle behind it. But also maybe we want to experience it firsthand, 对吧？所以我们不是光说不做我们 right? Just talk about it. We test it. We actually embody it, right? We know exactly what we do. Hence, you know exactly what it is. So don't be fooled by it. Also, don't be there. So, and again, this is going to be continue to evolve very, very quickly. You'll see, right? This is on the honestly after we release the book. I mean, we really is non-stop. Everything gets updated on a daily basis. New version, new correction, and new things, right? So, and you are welcome to contribute to this. right? In the future, all the code data will be also shared here, right? Even teaching material will be here. Also, there's a Moodle version, but that's all the cited, the basic teaching, maybe homework assignment will be there. There's a Moodle page, you should get used to it. That's sort of the university internal course website. Usually the TA will assign homeworks, post the solutions there, and so on and so forth. That you will learn how to interact with that interface. But this will be the primary site. You get familiar with the courses, the materials, and so on. And also maybe the TA you can help, right? Maybe we'll ask you about the experience. Maybe we'll do different models with different methods to train. Supervised fine-tuning, reinforced learning, different ways, how to improve the model's understanding. Basically, by the way, there's a huge right? You will see it towards the course, right? The big model, do they really memorize the knowledge or they actually understand the knowledge? Okay, what's the difference between understanding and memorizing? Right. So how do we push the limit of the current technology so that those models can better understanding or memorize in the good book, help you, or understand them to help you to understand? Right. So I think the TA or all of my students will push that. So you can see, you can be the first-hand evaluators for that. Right. So what is memory? What is understanding? Right. Just since we're on the topic of understanding, I'll just distract a couple of minutes. We're probably going to release this week. We're going to release another report, and also probably that. So everybody about all this deep learning model is trying to do inference, right? To do 推理, 对吧? I say there's always the inference. They're very deep. They can 得这个奥林匹克金牌，对不对？好像今年哈。Probably it's IMO gold medals and so on and so forth. But then how they really understand? But somehow if you ask GPT-5, 对吧？3.1和3.09到底哪个大，对不对 ？Still, right? 3.09啊，对吧？3.1啊大于3.9啊，对吧？Don't, if you don't believe it, try yourself, okay? So the question is, how do you really test the language, the mathematical skills, right? If they aced, they got 100 points, 他得了100分，这个 benchmark 上得了100分， do they really understand what they're doing, right? So the question is really about understanding, right? Understanding what is the large language model, because today, this course, you will learn from the principle, what behind those models. But this is the first. But also another question is even understand the mechanism, we still want to know empirically what the limit of those mechanisms can do or cannot do. What they can actually do, what they cannot do. That still needs to be evaluated, right? Where that boundary is, right? So that's also a very important question. So here is the report we're going to release. Actually, it's about 100 or some pages. There's a bunch of people actually did very careful. The kids from Berkeley, mostly from Berkeley, and by the way, majority are actually IMU 金牌, right? Those are all the 北大这些数学的这些第一名、第二名. They actually went to MIT, Caltech, Berkeley, Stanford as a PhD, right? Those folks. They're really curious about what the AI really can do. They did a very, very careful evaluation about right, mathematical knowledge, understanding knowledge, computing skills, and all the different skills, right? So they did a very, very thorough evaluation of ChatGPT, the best model there is, and also compares 0.4 median high and so on and so forth, right? So those are considered the best model out there, so that they actually can help you demystify. So what I'm trying to say here is that this course will be about understanding the current technology, and the mechanism behind it, but also will give you ample opportunity to understand, understand that mechanism, what they really can do, cannot do. Okay, then leave the question open: is what else have not been done? What the current model cannot do? Then how do we reach that? How do we break that limit, right, for the future? All right, enough about this book. Let's get back to the lecture. This is a time to pause a little bit. Any question about the course? Any question? I suppose most of you are graduate students, right? Any undergraduate students? No? Okay, good. So, uh, so the course is, you wonder, this course, the book is written at least with ideas for senior undergraduate and beginning graduate students. So people probably had a little bit experience with deep learning as a tools, CS students or E students, had a little bit of background with statistical learning. And your background should have, the prerequisites is actually, we try to make it as little as possible, but at least you should have some linear algebra, statistics, basic statistics, probability, and also some familiarity with optimization. We'll probably review a little bit about some of them, but some of the classical, statistical models and the basic models and linear algebra and optimization will help. Basically, undergraduate mathematics, undergraduate training in signal processing and some of the related area, statistical learning. So it should be enough. But as I said, right? So you can never be ready to learn something new, okay? So just learn it. If you need something, you don't, remind yourself, there's plenty of resource for you to catch up, as long as you dedicate your effort to it. Right. So any questions? The 1 hour training in Chinese students is very shy, right? They don't talk, ask questions, right? So that's why we designed a chat box. Okay. So you guys, hopefully you dare to ask questions to the chat box. Right. Question? Tianze, questions, do you log all the questions in the chat box? Yeah. Yeah. So the point is that we're going to do something we don't know, right? So this is the first time. We have to do a lot of experiments, have some fun, right? For your question, we wanted to know in the future, right? We want to know what the question student ask most about the book, right? Maybe the currently chat box may not be perfect, but we will find out the statistics, what the question gets asked most, what the people are mostly don't get it, right? Help us to produce maybe answers in the future. We can retrain the chat box that help us to improve the quality, okay? So that the future student, when they ask similar questions, will get better answers, okay? First. Second is that, and also we're probably even planning to do with our homeworks, right? This year we give you assignment, you can even try to use ChatGPT or use the chat box to help you, right? And in the future, we're going to train the chat box with the solution to this semester's homeworks. Force teachers, TAs in the future, when they teach the same course, they cannot assign the same homeworks anymore. But you can ask them questions about the homeworks being taught before to learn from it. Right? The chat box can produce a good answer. Then you can learn from the solution yourself. Okay? So we'll do that. We'll try to do that iteratively, right? But anyway, try to be corporate with the TA. Do whatever he asks you guys to do so that you will pass the course. All right, any other question? What's that question? Yeah, there's a lot of things we can do with also English, Chinese, anything you guys, I suppose who doesn't speak Chinese? Nobody? 所以我就用中文讲了那个。No, it's okay. I'll have to use English. We're here. No, you have to learn English, okay? As I said, the new language is important, right? You don't have to be a Shakespeare, but you have to be language coding, right? Right. 可能以后不能靠它吃饭，但是肯定有帮助啊。这个是 you have to learn English, all right? That's why we do provide a Chinese version, okay? To help people who are still struggling with English. Maybe I know, I've been a PhD student before, right? I know Chinese the first semester maybe can be a little bit struggle with understanding, hearing, reading. Yeah, but you have to bite the bullet and learn it. Just like the first time you learn coding, okay? You have to learn at least one language. So help you to do that. Occasionally, we will use English, Chinese, and also the Chinese version, right? If you identify any problem, send GitHub they can submit a request, right, in Chinese, right? So maybe all the Chinese will goes to you guys. One point, you guys can probably incorporate in changes, right? Go ahead, question. Hmm? What do you mean, LERF? What do you mean? Reply to 千者, okay? As his domain. Okay, everything is a beta version, right? Good. Maybe you ask the same question. No, it's okay. So you actually can improve. Talk to, have some fun with it. Again, this is the first time to help you to play with it, right? Okay. But if the chat box doesn't help you, you always have the textbook, okay? All right, you can always ask me and also ask the TA, okay? Good, thanks. Any other questions about the course? All the question about the chat box, I'll do that afterwards, right? After class, interact with it. You can also help with the TA to help, right? This is part of the research actually, right? Good. And we're also trying to think about it. There's a lot of team of people trying to develop tools for do research, right? There's a lot, you heard a lot of the deep research. We don't need a PhD anymore, right? Elon Musk says that, well, really? Well, so you have to understand, right? For your own job security, right? So you have to understand what so if someone ask you in the future, right? We don't need a PhD anymore. Well, you'll be in trouble, right? So you have to defend. Oh, no. Those, I can tell you what those lab models can do, cannot do. What I can do, those models cannot do. Okay, that's at least what you can do. So okay, anyway, no more jokes. But this is just for us to get a little bit serious. Back to the lecture. One. So this is a talk I've been giving recently about the nature of intelligence. Kind of an overview of what we do in this course. And I'll try to go through that. It's a different version of it. I mean, some are short, some are tall. And the same talk I can give in 15 minutes, but I also can give in 3 hours. So that's depending on how much you want to hear. As I have said earlier, right? So last decade or so, there's been a lot of excitement, curiosity, excitement about the intelligence, right? The technology development is very, very fast. 日新月异, right? 每天的千变万化, very exciting as well, and very stressful, right? 可能明天就没工作了, 对吧? I got a lot of questions these days. Right? My friends' kids. So, Professor Ma, what my kids, which major that he should go to graduate student? I mean, there'll be, by the time they graduate, there's still jobs there, right? So I don't know, to be honest, right? You should be curious at least, right? It's quite a lot of, stressfulness, right? Oh, you also heard on the other side, all these guys get paid $100 million, right? Dollars, by the way. Right, to get a job, right? One job get paid $100 million, other people are losing their jobs. So what the heck is going on, right? So there's already people become very anxious， 就大家很焦虑啊，很焦虑，又兴奋又焦虑，对吧？就是说你到底是该在兴奋那边还是该焦虑那边，right? So this is, I mean, same with us, right? I don't even know teacher, right? 我们都说这个 AI is revolution, right? 革命，我说首先可能把我们老师的命革了，对不对？ Maybe we don't need maybe coding, right? 这是马龙的命革了 ，right? Maybe the 马龙 will first 革了自己的命, right? It's actually possible. You never know that. So, and there's a lot of excitement, but also technology, of course, right? Now the infrastructure, billions of dollars, literally, right? Each cluster, billions of dollars, right? And billions, trillions of data, right? Massive in system, massive software, massive data. Right, billions of people using those models, right? So a lot of things. What is, we're in the age of artificial intelligence, right? We're marching to general AI. We are marching to general super intelligence, right? 开始是 AI， 然后这个 然后 AI 后来挣不到钱了，融不到钱了，就叫 General AI，right？General AI 融不到钱了，General Super Intelligence，对不对？又再融一轮，right？就是这个是 very very interesting 啊。那个 Super Intelligence 融不到钱了，这 Embodied AI 又来了，对吧？You know，所以you know，所以这个 So what is intelligence? And again, despite all the technological advancement, what is going on? Right? Again, there's also actions. There's a black box. So on one hand, very people are very excited about it, but otherwise very worried. Right? Some people say, "Oh, this guy is very very dangerous. This model is become conscious." Right? 谁说的我就不说了啊，大家都知道，right? Right? Just a couple of years, a couple of weeks ago, right? Oh, it's become conscious, self-aware. They're going to lose control. Human cannot control them anymore. They're like a nuclear bomb. They're like a virus. They're going to wipe mankind off the earth, right? 对吧？我们叫 doomers，这些人叫 doomers，就是这个 doomsday，知道这个词儿吧？doomers 就是这个，就是这个末日审判啊，这个末日论者啊，就是这个叫这个AI 变成 conscious，对吧？就跟这跟好莱坞的电影一样啊，这个开始反抗人类了，控制不了了啊。现在我们要 build maternity，要把母性加到这个 AI，要给机器立心啊，这个对吧？变得很玄乎，对吧？要有母爱，要有这个母性，还 got to have like a maternity instinct，right？So that otherwise they're going to, you know，就是我们就问，但是the people who say AI is very dangerous, it's very ironic，对吧？很奇怪，right？The people who say, right, Elon Musk, Eric Schmidt, the people who claim AI is very dangerous, going to kill people, kill humankind, mankind, are the one invested in AI the most，对不对？包括我们的 Hinton，对不对？他的学生去融几十亿美金，他觉得挺好，对吧？但是别人去做 AI，他很 worried，OK？、那 Elon Musk 也是，right？所以地球快完蛋了，AI 会把人类毁灭，所以我们移居到火星去，哎，但他自己是投的最多的啊。Eric Schmidt is the same, right? The guy, he's the 白宫的这个 AI chief warrior，对吧？对吧？就是要 sanction China 啊，sanction 这个 sanction 那个，对不对？别人不能有啊，既然是原子弹，我能有，你们不能有，对不对？哎，很简单的道理嘛，对不对？这是 scary，right？啊，if it's 病毒，it's a atomic bomb，right? Of course, you know other people cannot have it, we have it，所以我们可以做，你们不能做啊。大厂可以做，小厂不能做，对不对？对吧？我们可以闭源，开源不能做，对吧？就是这是连在一起的，OK？所以我们有芯片，你们不能有，这很简单。哎，我自己可以疯狂的买，现在 XAI 在建100万卡集群，OK？但是 Elon Musk 也会讲，那 AI is destroying mankind，OK？所以 we are getting prepared go to Mars，OK？啊，所以这个是很有趣的一个现象啊。So what do we do? So hence, as a scientist, right? So then academia, our job is to actually really understand what's going on. We cannot. So it's like 就是说你看嘛历史 if you don't know a little bit history, right? You know in history anything significant, anything has impact on humans' life. If it stay as a black box, it always leads to what? 巫术，对不对？迷信，最后宗教，对吧？No exception. Look at that history: Chinese, Indian, right? Mediterranean, everywhere. Look, this is human nature, right? As long as something mysterious, something people cannot understand, right? 天狗吃月亮 right? 马上杀鸡宰牛，对不对？谁 gets rich？巫师、国师 gets rich, right？很多人愿意当巫师嘛，当国师嘛，对吧？当宗教领袖嘛，对不对？现在我就不说谁了，对吧？有些人就是想当这个东西嘛，对不对？啊，全世界到处去 preach 啊，这个东西危险的不得了啊！我知道它是什么，你们都不知道，对不对？Oh, okay, I'm the only one can talk to it. Okay, I'm the only one understand it. You guys don't, right? Scare everybody, you know, everybody off, right? So this is very strange. I mean, it's just human nature. It's, no matter who he is, right? Doesn't matter who he is, right? It's just human nature, right? It's a history. If you understand it a bit, it's always like that. Until someone, right? Newton write the equation. 高中生都知道，对吧？天狗吃月亮怎么回事？Right? Suddenly, so be it. right? It's not that. So you have to be able to understand. That's what science is doing, right? We have to understand things. We have to explain things, right? That's why I like the Richard Feynman's group. Right? I mean, we have to create everything from first principle, from minimal assumption, deduce, understand everything. Okay, that's what science, that's what mathematics is all about. 对，当你真的必须能把它必须重新 create 出来，用理论用原理把它 create 出来 ，right? Create it out, then you be able to understand. Once you understand, there's no mystery about it. 哎，啊，对，就不会有无私国私，对吧？这些宗教了，对不对？那很简单了嘛，对不对？那话很多人就you know they manipulate people's fear, OK? 利用人的恐惧嘛，利用人的好奇心，对吧？赚钱，对不对？对，就跟中国现在的这个短视频都是靠这个，因为好奇心嘛，对吧？就是靠这种东西。You can actually convert it. So this is actually saying the question is how do we do this, right? How do we learn? Actually, this is a question, right? In the past 8 years, we actually have been on the mind. In the academia, the researchers, scientists, we need to figure out what is intelligence, or what is artificial intelligence, right? Can we explain everything? All right. Let everybody talk about machine learning, 对不对？啊，都讲我们要 machine learning， why， 对不对？所以你可以问一问，就是他到底为什么要 learn？What to learn？Why do we want to learn？How to learn？然后当你搞清楚 what to learn，what's the purpose of it，then maybe you can study how， 对不对？你连目的都没搞清楚，你就在研究这些，对吧？这些模型在干什么？哎 ，Why do we have all these different models？千变万化的技术，对吧？每天都对吧？一会儿改这个啊，这个又提高了2个点啊，这个又提高了一个点，对不对？对吧？100万卡啊，那个20万张卡好像提高了1个点啊，在50万张卡又提高了2个点啊，又是地表最强 AI， 对不对？又来了，对不对？每2周弄得很焦虑，对吧？好像你就是还有某些同志就说，那是 a lot of people just say 啊，很奇怪，对吧？这个经常一个新东西 update 就说啊，这是最后一班车了，这是最后一班车了，对不对？再不上你就落后了，对吧？再也没机会了，对吧？再不投资，对吧？再不 all in， 对吧？再不 all in 你就没机会了啊！真的吗，同学们啊？想想啊，很奇怪哦。There's a lot of phenomena, right? Very curious. 这到底要干什么 ？Intelligence 到底要干什么？为什么 machine 我们要 learn？Animal 要 learn，human 要 learn， 机器要 learn， 这躺平不行吗 ？Can we just 对吧？不要那么卷嘛，对不对？不 learn, right? What's wrong with not learn anything, right? What do we want to learn? What do we can learn? What's worth learning? Why? 你把这个搞清楚，很可能才知道我的。所以我们有时候说中国的哲学，对不对？分量，对吧？我们都说道和术，对不对？过去你们发现没有？过去10年，这段话可能只有中国人比较理解，对不对？过去10年，实际上你看我们的技术就是术嘛，中国人自古就讲术者千变万化嘛，对吧？茅山道士，对不对？啊，对吧？包括中国的各种的，对吧？补房子都是术嘛，千变万化，看起来杂乱无章。但是过去大家总觉得槽点思想，对不对？没有指导，没有原理啊，没有理解，对吧？就缺少大道至简，对不对？道理是很统一，很多个我们看见的千变万化的术，很可能只是同一个道理的表象而已，对不对？所以呢，有时候我们就在想，对吧？就是说 maybe or maybe there's some simplifying principle behind all this. What do we saw? Different networks, different systems. They're just try to do the same thing. 条条大路通罗马 ，all roads to Rome, right? 搞清楚它的目的是什么啊？道路可以千变万化，技术实现方法可以千变万化，很可能 they're all trying to do the same thing. Once you figure out that role, maybe the rest is much easier to understand. Okay? Maybe we should do something more of that. 不然的话，有人就会说它是原子弹，对吧？它目的就是要把人类给毁灭了，对不对？对吧？那你有什么办法？你也没办法，对吧？So okay, this is so the question is to find the purpose, right? Find the purpose of what do we do, right? Right. So this is a slide actually inspired by Chu Cheng Tong. Earlier this year, I had a lunch with him. He asked Yi, is there any mathematics behind AI intelligence? Is there a mathematical principle, or what is the mathematical problem behind AI? At that time, I told him, yeah, there is. We can formulate the question about intelligence as a rather rigorous mathematical problems. So that's what this course is about. Second, he also curious about what is current AI method can help mathematics. So he asked me a question: 现在的大模型能做反证法不？我说好像还不行啊，据我了解好像还不行啊。当然我们的学生可以测试一下啊。So he's also curious because 陶哲轩曾经在网上对吧说现在这个 AI 革命了，要把 math 革命了，对不对？现在陶哲轩好像比较清醒一点了，对吧？2年前这个陶哲轩以前对吧，就是把一帮数学家搞得很焦虑，对吧？他把老邱对吧，邱成东这个搞得很焦虑，就数学要革命了，要被 AI 革命了，要完蛋了，对吧？所有的数学问题都要被这个 AI 解决。这个好像现在他好像这2天的这段时间的 blog 变得比较那个理智一点。But then later on he said, 那是邱先生的格局很高很大啊。那个 so the 他说这个世界上就只有2个问题值得研究其他都是小问题一个就是宇宙怎么来的一个是生命怎么来的，对吧？宇宙呢也是来的，因为他研究恰拉比猜想嘛，对吧？弦理论嘛，就是给宇宙建模，对不对？所以为什么邱先生的东西在数学界和物理学界都有很大的影响 ？OK， 为什么他在数学界的地位很高，物理界的地位很高？因为是 that his work actually really try to help understand how to build models for universe, right? We know that I use the string theory. Almost all the known the laws, physical laws, can be described as 9-dimensional or 11-dimensional manifolds, right? 从宇宙大爆炸到现在，所有知道的物理模型、物理规律，可以用9维或者11维的弦理论的模型统一在一起，对吧？所以but another problem is about the life begins 怎么开始的？生命在干什么？那么我们可以讲，那简单来讲 ，right? Universe is physics at work。那么生命 is actually intelligence at work。现在我们的理解。因为这句话实际上很有趣，这虽然是一个哈维尔是一个政治学家，但是他讲的这话很对。The constant increase of entropy is the basic law of the universe. So is the basic law of life to be ever more highly structured and struggle to against entropy. 所以他实际上这句话解释了2个很有趣的现象宇宙的熵是逐渐增加的这是热力学第2定律，对不对 ？The second law of thermodynamics， 对不对？一个封闭系统的熵一定是熵增的熵会不断增加随机性会越来越大最后达到一个平衡台就是一半杯热水，半杯冷水，最后自然会温度达到一起那么 intelligent life is exactly opposite. Life is 在这个混沌里面找规律，是 find what's predictable. What is outside the environment? 我们外部世界哪些是可预测的？利用它来生存，对不对？明天会下雨，所以出门打伞，不要淋个落汤鸡，对不对？那个地方有水所以不会渴死。那个地方有苹果树可以去吃，对不对 ？You find what's predictable， 而且苹果树只有在某个 season 才会熟，对不对？要记住，春天、冬天是没有的 ，OK， 对吧？不用去找，对不对？春天该吃什么，冬天该吃什么，夏天该吃什么，对不对 ？So those are the things about the behave, the environment, know the knowledge about it, right? Help you to predict. The world is predictable, so you fight against entropy. Right? So you can predict things, right? 所有的 physical law those help us to predict what's going to happen next second. Right? It's about that.